Klump is the Vice President of Design and Building Retrofit. I don't have their title exactly right, but if you don't know Julie, you got to get to know Julie because she is a wizard. I don't know how she does so much in so many states, but like the number of passive house projects, the number of testing new technologies like our pinhole insulation, slow expansion foam product in Massachusetts. And now this, like the first mover in this decarbonization space of existing buildings, affordable housing in Massachusetts. So I'm just gonna hand it over to Julie. And is Ken with you, Julie?
Yeah, and I was going to introduce Ken. He's my passive house sage. Ken Newhouser is our CPHC on this and other projects. I invited him to join me and answer the hard questions, and also to just shout out to him because we couldn't do any of these projects that we're excited to do without Ken and his team at Building Evolution. Salem Heights. So, obstacle or opportunity. I think the obstacles continue as we wrap it up, and they will probably continue for a while based on some of our choices, but became a real opportunity, exciting for me in terms of getting to really dig into a deep energy exterior retrofit and see how we could really improve indoor air quality and comfort for residents. There you go. So just really quickly, preservation of affordable housing, we're in 12 states and DC. I like to overlay the states where we are present over the climate zone map, just to sort of show that we're just about in every climate zone. We have old buildings, which lend themselves to a whole host of challenges in terms of good performance, and lots of new construction passive house, which I hate to say it on the screen, but it's getting a little boring compared to these deep energy rehabs that we're digging into. So this is Salem Heights. We bought this property in 2003. The whole naming of POA and preservation of affordable housing is that the goal of the founder was if affordability and affordable projects were threatened in terms of this one was certainly had affordability contract had run out, was up for sale, easily could have been bought by a market rate developer and converted into high-end apartments or condos. So we worked with the city and a low-income housing tax credit allocation to buy it, but when we bought it, we didn't have enough money to do sort of a typical POA rehab. So it's 281 units, and it was built in 1974. The curious thing about 1974 is that there are no shelf angles. The brick is supported from the ground up. And our intent when we started this project was 100% kitchens and baths, and maybe some repointing, maybe a new roof. But what we discovered was that given the brick was supported from the ground up and the details, while in this image are accurate and are what's supposed to be there, we didn't find this everywhere. We found a lot of repairs. We had water coming in certain locations and certain weather conditions. And the image with the black hand, that's actually Ken's hand, I think. But this shows the tab and the pin, which was the tab is welded to our structural steel and the pins installed at the end. And those were supposed to keep the brick up and attached to the building. But what we found was that was not actually the case. We opened it probably, I don't know if we ended up doing 20 openings, some to sort of just see if the structure really existed, where it existed. We wanted to see what the condition and capacity of the light gauge metal studs that you can see in this image on the left, structural steel concrete deck with a light gauge metal in between on each floor, with the masonry supposedly hung on those light gauge metal studs. So what we went with was an armor wall to structural insulated panel, R21, out of the box. And the beauty of it is that, as you can see in this image, I don't know if my cursor shows up, but there's the insulation, and then the structure, the sheathing is on the outside. So once we attach this to the studs, then our cladding attachment becomes completely thermally broken. So it allows us to put whatever cladding we want on there. We achieve the a rain screen, the fire protection, and the U value, or the R value that we're trying to achieve. And you can kind of see the tab in the pin and section in that one detail. So this kind of shows you the three different phases. You can see the brick, you can see the armor wall with all the black sealant on it. That's the only way you get it to be airtight. The pink color is the air and water barrier. And then to the far right, you can see some of the metal panel going on. You can see how we access this building with mass climbers. On the brick, the square is just highlighting that. You can see that a lot of through wall sleeves that were used for air conditioners provided by residents. We also replaced all the windows and reduced the height of one of the windows that you'll see in future images. So this is, you know, it looks even more further along now than it did, but one just some images to see how it the looks transformed, and also to just sort of highlight the Minotaur louvers that you can see in that one yellow square. Another cool thing on this project is that it sits up on a hill. Given the density, you know, trying to approach net zero is a little tricky because of the roof size and density and electric load. So we decided where we could, we wouldn't put metal panels on, and we would put solar panels on. So we have panels on west and south facing walls. And I think you, oh yeah, you can see the capacity of the wall. And then this roof of this first tower will get us some good juice as well. Unfortunately, the other building, when we went to replace the roof, we realized the decking is not strong enough at the moment to support the PV that we wanted to put on it. So we have to sort of wait for a lighter panel or some way to reinforce that roof to get another 120 or more, probably, because this roof has cell equipment on it. So mechanically, so we thought, oh, let's look at VRF on the roof, and we'll put some ERVs per floor. We'll run the ductwork down the hallway and into the units. And then when Building Evolution went out and did some analysis and peeked their heads up above the hallway ceiling, what we were discovered was that there's this giant steel beam that ran over the doors on one side of the hallway. So there was no way for us to duct into units from the hall to provide fresh air. And the exhaust riser, current codes require that any new shaft be self-supporting in a fire. So it was going to be very expensive for us to build all those risers that we would need in order to avoid the steel. So we went for the Minotaur, which some of you may have heard of or met Alex at conferences. It's HVAC in a box, heat pump. And so we built closets on the exterior of each unit. Most of the time we did it in the bedroom in order to leave the living room square footage intact. You can see in the AXO up at the top how that closet works with the intake and the exhaust staggered up and down on each floor. And then in the floor plan, you can see sort of the supply to the bedroom and the living room, exhaust from the bathroom, exhaust generally from the kitchen. And then there are exhaust boost controllers, and then a main controller that is in the living room. So this is what it looks like installed. These are the closets. You know, this is their Minotaur has got some amazing ductwork that's absolutely silent that they want from the unit. And then as you get closer to registered distribution, that ductwork has to be installed. And every step of the way we did, we sort of had some learning curves. You can see in the image with the arrow that there's still baseboard. We wanted to leave the baseboard in place in order to test our enclosure to see if it was robust enough for the Minutair heating to satisfy the units. So in order to have those two systems work together, we installed a zone valve to the baseboard that also connects to the Minutair, so that the Minutair can be our primary source of heat, and the baseboard will just come on in order to satisfy a temperature that the Minutair can't accomplish. So I think that's all there. So the meat of this presentation, and probably why we're here, is to really talk about, we're doing all this enclosure upgrade, new roofs with lots of insulation, good windows, low energy heating, cooling, ventilation system. So why not passive house? So again, there's some obstacles and some real opportunities here. So, exterior wall with that armor wall is R21. A little bit of existing fiberglass bat. And so roof, we got it to R30. We had to put a new deck on one. The other one's on existing. Windows are, triple glazed. They're okay. Much better than what was there. And obviously the Minutair, the efficient HRV. So how does it look in terms of performance criteria? So it passes, right? And Ken explained to me that this source energy, the reason we have a red line there is because the source energy is really over 4,000, but for some reason, when the Woofy model spits this out, it still has the black line or the threshold sort of marked for an older source energy threshold. So anyway, so look, green checks, we're all good. So the possible challenges here, and probably for a lot of you, they're really obvious, right? But we'll get into those. Performance standard, we might hit the performance standards, but what about all the prescriptive standards, not only in Phius, and then all the subset Energy Star, zero energy homes, Indoor Air Plus. What about those requirements? So BEC evaluated 342, which sounds like a lot, but it was a good exercise to sort of see on a rehab which ones we would easily meet and which ones might be a little bit of a challenge. So these were the checklists, as well as Phius prescriptive requirements. So this is sort of the outcome of that, right? We, easily we can meet 184. Some may be a challenge for rehabs, all rehabs. Some we need to work with Phius on, and Phius has been great. We've met with them several times. We talked to them about maybe even being a pilot for their real Revive product, but program, but they wanted us to do this through the new construction because we were a little ahead of their Revive, setup or program. So, and then, also there's some things that we might be able to do, but we might not be able to verify. And then there are just, there are a few that don't apply to retrofits at all. So, air tightness, specific issues to the project, and then just general retrofit projects. So air tightness, we achieved this with the sealant, good flashing, and that's a lot of surface area, right? So maybe we have a little bit of cushion in terms of air tightness with the size of this building. We did do a guarded blower door test early on in the building on one tower, three floors, isolating the floor in between, and we plan to do that again on the same exact floors once we get to that. We get to that point. Roof to wall. There was a lot of struggle on this. The GC wanted it to coordinate in terms of timing, in terms of running up the metal panel in coordination with the new roof, and it didn't happen. So there were some some sequencing that had to be resolved in order to get that right. And this is sort of what the detail ended up in terms of how we did, what we did, when. And if people have questions about that, we can get into that after, but just to kind of show you our thickness, that's a lot of wood. We realized that we really pushed back on that to try to see if we could minimize that. But that's what it looks like in the end. There you go. Here's another air tightness concern, is this wall to slab, which not only does this sort of pose an air tightness challenge, but it also, we don't have access to that slab in order to improve the thermal performance. Windows did fine testing, so we were excited that we didn't have any issues with our windows. The image that I showed earlier about all the louvers and the Minotaur, and you can see on a per floor basis, there's 2 per unit. One's the intake, one's the exhaust, and then it flips on the unit above. Trash compactor is on the exterior of the building, and we probably could have tackled that and made those walls sort of exterior walls and try to get that out of the, and we can still do that, in a future project. So prescriptive, this is, so when we start to look at Phius's prescriptive, we start to get real close on the heating load, even with an okay air tightness on the exterior or some cushion in the exterior. So here's some of the details that are a trick that you might find in rehabs. This is a garage ceiling. Ultimately, what we did was we ran the armor wall down the side that we were doing all over the building, and then we turned the armor wall to create the ceiling of the garage. That kind of gave us the air tightness and the R value that we needed in order to protect that floor above and protect the residents that are living there. So, passes Whoopi, but what about Energy Star? Another trick I showed you on the air tightness for this air slab, the slab to wall. This is a detail we want to do, and we are doing it everywhere that we have to excavate, change the grading, do any repair work on the edge of the building from construction, but it won't be 100%. So as we get opportunities to do this slab edge, this is the way that it's been recommended to us to address that slab edge, or to address the slab itself, since we don't have access to it. But we didn't necessarily get to do that 100% of the time. We only, and it's probably, I would say, less than 50% of this perimeter was done. The other thing on this building that is kind of a disaster in terms of passive house is this connector. It is wide open. It is not, there are not doors from it to the other towers. And it actually, from underneath the floor of this edge of it is just completely exposed. You'd have to do a treatment of that similar to the garage ceiling. So Energy Star requirement. So this is the one that is going to take a lot of time, and probably we will continue to do it as we do more turns of the unit, given that we had to spend money to do the enclosure. We didn't get to do all the unit upgrades that we typically do. But what we do is when we touch a unit and we do flooring, we seal that joint, wall to floor, electric J boxes on the exterior, plumbing penetrations. We typically do that on our turns, and we kind of had an expectation that our builder would do that whenever they were installing new cabinets, etc. So this was our pre-construction testing results. And this is post. So you can see that, well, let me just go ahead and do the next slide, because and the F is not a bad word, I promise. Well, it is, because it says fail, right? So we did pre-construction compartmentalization and then post, and we actually blew it on this. And we blew it what we identified was, and this is an existing unit, this is something that we wouldn't expect our builders to do. But we know that we're gonna have to hit these spots. Ken and some of his team went in and they taped all of these issues, and they were able to get, they were able to half the air tightness in the compartmentalization from what we started with and what we tested to the second time. So we know that in order to get close on the compartmentalization, we're going to have to hit all those existing conditions, and then we're just going to have to make sure that our builder hits all the holes they're making, the duct boot seal. I don't know why that's such a challenge, but it is. And then any new ducts that are coming in here at the ceiling, those all need to be sealed. So those are on a punch list. We are working on those. We will go back and make them do all the plumbing penetrations, etc. So you can see that when we taped it, we knocked it in half, and it wasn't a great tape job, and we can't use tape for sealant. So we're going to have to go back in there and take care of this. So did we get there? So, you know, we'll see how the air tightness ends up. You know, we obviously didn't hit the slab. It's possible to get to it, but the slab edge could probably make a real difference. So we'll have to see what happens there. And the connector, there are some ways that we could probably isolate that connector, but we just didn't have the program didn't allow for it, and we sort of didn't really have the money to do that. So, and obviously we talked about that the compartmentalization was going to happen later. So it remains to be seen. Before we open it for questions, I want to show one other project that has come from our Salem Heights efforts. A neighboring POA project of Salem Heights that's actually one of 4 buildings. Similar, not as big as Salem Heights, senior properties, much smaller units, but real nondescript brick buildings. The windows are not great. The roof needs to be replaced. It's fossil fuel systems. And so we did a feasibility study with Onion Flats and a GC and Building Evolution and a mechanical and electrical engineer to try to see how we could build these panels offsite, bring them in, install them similar to the Realize Energy Sprong design that the Dutch are doing and RMI is sort of promoting here in the US. And we use Salem Heights cost to sort of see if we could make this work on a cost basis. We want these buildings to all be passive house, and we want them to get to net zero. One of the big things we learned at Salem Heights is it was an occupied rehab, and we thought we had a good plan. We thought the GC had a good plan, but it cost us over $1 million just to manage residents in an occupied rehab. So that's a cost, and it's also hugely disruptive for residents when you're going in and out of their units in a not organized way, or on multiple occasions to upgrade their units. And some of it it's not something they see. If they didn't get new kitchen cabinets, you know, they don't see the benefit, although the health benefits are there, the comfort benefits are there, and that remains to be seen. And post-construction resident survey will get some real intel on that. So happy to answer questions, talk about cost, talk about you know, what sort of hurdles we hit that we couldn't seem to overcome. But thanks for having us on, and we'll take any questions.
This is just so interesting, and I think it's very timely with Phius having their retrofit summit coming up. This is exactly what they're thinking about, I think, in that process, and how some of these layered on credentials might not work exactly right, even if we would ideally want to see them in new construction. So I think, Sean, are you going to coordinate questions now?
I'm going to take care of questions, but we're going to go to Kim first. to look at sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Aero Aggregates, Brennan, Brooklyn Solar Works, Euroline Windows, Coltraco Ultrasonics Micro Air Leak Detector, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
All right, well, let's dive into questions. We've got a good list here and good questions, so we'll do our best to get through them all. Julie, thanks so much for a great presentation, and we're going to start with Carmel. I know you had two, so maybe pick one, and we'll put you back in the queue for the second one.
Thanks, Sean. Actually, Julie, you answered the first question, which was whether the tenant stayed in place for this rehab. And I'm sure that brought all of its own challenges and maybe changed your scope of work, depending on the situation. But my other question was related to the compartmentalization testing that you did. It seemed like those air sealing measures weren't originally in the scope of work for rehabs. Do those results and what you learned change how you move forward with specifying air sealing in your future scope of work for rehabs?
So we have a basis of design, which is a web-based platform that anybody can access. And it has a whole compartmentalization requirement. It's in our architect's contract that they have to meet those performance criteria and some design criteria. It's in our builder's contract. So I think, and I probably wasn't exactly clear, there are some existing conditions that are obvious, right? Plumbing penetrations. There were some that were kind of surprising to us. The baseboard, the holes where the baseboard, came in and out of the unit. But the plumbing penetrations where there's new cabinetry going in, new vanity in the bathroom, new flooring, all of those joints should have been addressed by the builder. Some of them are on a punch list. Some of them are yet to be sort of highlighted for them. But our expectation is that either during a rehab or when our site staff comes back and does a turn, they update a unit, flooring, cabinetry, whatever, that all those joints, in order to improve compartmentalization, are addressed.
I see. So those were already in the specifications, and this was your proof to the GC of why they needed to do that.
Right. Exactly.
Thanks.
Yeah.
Thank you.
Great stuff. And so I guess kind of question two is again retention with the construction team, not only for this project, but the one that you showed next, like across the path there with Fairweather. Is it the same construction team that's working on that? So are you starting to get similar teams to work on stuff, or is it brand new every time now?
It seems like that happens more in our new construction. I don't think we've done this enough. And because that one is going to be offsite, sort of built and then craned in, it's a little bit different skill set. We'll be doing design build with an enclosure manufacturer, and probably some design build with the actual builder, the actual GC on the job. But in terms of consultants, it's the same. It's BEC, and Clear Results typically our verifier. We let them do all the testing, and then we have a mechanical and electrical. So the consultants seem to be the same, but the builder, maybe because it's a different way to build it, is different.
Gotcha. Okay, sorry to jump in there in the question queue. I just had something to share. Paul, over to you.
Seeing that the sheathing is outboard of the insulation, and the insulation is against the studs, when you attach the cladding, did you have to attach back into the studs, or were you able to attach only to the sheathing?
No, just to the sheathing. And that's sort of the beauty of that. So the structural engineer told us how many, screws and
Right.
spacing to connect the armor wall back to the studs. so that it would be strong enough to support the metal cladding that we put on that only had to be attached to that sheathing.
Yeah, I appreciate that. I might be asking you for a referral to that engineer. With our panels, we get that question a lot. I've been relying on a document from the SIPS industry, but this would be even better. Thank you.
Jay Waterman, you're up next. Jay?
Yeah, I was just asking about the fact that the building is almost 50 years old and whether you had considered using historic tax credits, and with that come a lot of limitations on the cladding of the building. Was that a consideration? Needing more funding, sometimes historic tax credits can be used. I don't know whether you considered that.
So part of my master's degree in architecture is historic preservation. So I'm a proponent of historic preservation, but what our experience has been is that it becomes such a challenge with the National Park Service. The windows, we haven't found a triple pane window they'll accept. If it's a masonry wall, and a lot of them are triple, 3-wide masonry walls, it becomes really hard to do any insulation, that makes it any real difference. So I don't know if anyone thought about doing historic tax credits on this, but we do, our acquisitions team looks at that for anything over 50 years old. But this one, that would have probably really slowed us down, because we probably would have had to put the brick back. And we might have been able to do some, but I think Massachusetts fortunately has a lot of incentives that helped, and even more going forward. But the financing, seemed to work, which it was an increase of about $10 million for us to switch from an interior project effectively to an exterior project.
Heather Clark and I think Michael Hindle might be on that job. There's a Fitchburg historic rehab that they did get a triple glazed window approved, just so people know, because I think that's an important thing when you actually do trigger it. My question though for Julie is the backup gas heating system in this first winter. Do you know if it had to be triggered much, or did it seem to do okay? And especially that really cold event we had a few weeks back.
The zone valves are just going in. They didn't go in as the Minutaires went in. So the residents have had access to both sources of heat. So we don't know yet. The other thing that we're considering, which we didn't when we were putting the Minutaires in, is because it was sort of cost prohibitive, is there is a way to connect, I think, 200 max units together on a master controller, so that we can do, global limits or really check, performance issues, resident issues with each one. So I don't think it makes sense, or it's, it's really unfair to maintenance staff to have to monitor and change filters, not necessarily the filters, but to have to monitor 281 of these units, newish technology to everybody, residents included. So we don't know yet.
Just means that next year Julie's going to have to come back and give us update on the tenant surveys and how things are running, and just give us an overall update on all of her amazing projects. So it's include her in next March of 2024 to give us the update.
Sorry, Sean, I thought I'd jump in and answer Bev's question also. I can tell you that where those zone valves are in process of being controlled and not quite set up yet, all those units are overheating. So if we can't control the hydronic, it's, I was in there a couple weeks ago talking 80 degrees plus in units. People aren't complaining yet, but it's definitely warm in there without the control. So I suspect we'll be fine.
Great. Thanks, Ken. Again, appreciate being the friend to call upon. It's always great when presenters bring in, the team to help them out, and when we get into the, the fun conversation. So we definitely like the nerdy stuff. So thanks, Ken, for providing that input. John had a question. He's no longer here. He just said, can you share the checklist spreadsheet? So maybe we'll figure out how to either provide that. But John, if you're out there, email Julie and have that conversation with her. Continuing on, Nitin had a question. Sorry, looking at the project timeframe, how long did it take from start to completion? And then I think Bev did a great job of putting the cost of the project. And then the question of, discussing all soft and hard costs coming out of the condo corporation. Was the ROI calculated? And discuss the break even. So there's like 5 questions in there, but maybe just because of time constraints, just give us a kind of overall update on the ROI and some of the costing of how to make this project work and be able to repeat it.
I mean, I would say that enclosure upgrades are hard to pay back. The Fairweather project that I put up at the end, that's, $10 million, to overclad that building and change the mechanical systems too, but we'll save $130,000 a year, right? So how long is it going to take us in order to pay back $10 million with $138,000 savings? So there are lots of immeasurable benefits, right? Resident health, resident comfort. We're reducing at the Fairweathers, the numbers are that we're reducing our carbon footprint by 80% by converting that building to all electric. We haven't really done carbon analysis on Salem Heights, but that really makes a difference. And I think the incentives are kind of help us sort of identify those immeasurable benefits so that people aren't just looking for the payback.
And I'd add, like, when you have an emergency situation or like a water issue on an envelope, or there's some reason you got to reclad, I think the message is like, use that as a deep energy retrofit, right? The incremental cost is not enormous. Like Julie's talking about the whole number, right? Like, I think being able to piggyback on things that have to be done is where we need to focus to drive down costs at scale. And then, maybe we'll find more intermediate approaches. I mean, every building is not going to be able to energy strong. So we got to find more intermediate approaches that are, cost optimized, not necessarily cost. They're not going to, the ROI still maybe won't be there, but we don't want heating costs to be extraordinarily high, and we want people to be comfortable. But like, what else can we do that's not the full on energy strong, right? That's the big challenge.
Yeah, Bev, and again, we talk about resiliency with these extreme weather issues. I'm sure those tenants are just going to love the fact that they're not experiencing those extremes as the other buildings are. So, no, absolutely great. Thanks, Julie. Dale, you got a question about solar panels?
Yeah, obviously, in our early years of solar at ACES, that when you shade those panels and no shade there, how are you not losing the benefit of that whole array or a large portion of it? Are you using in-phase or what are you doing?
I don't know about the in-phase, but we looked at this really carefully with shading, and the lower, that's why the panels start at like 15 or 16 feet off the ground in order to minimize some of that shading. It sits really high, and there's enough area that the shading was not, it wasn't prohibitive for us to put them on.
That's not the point. The point is when you shade panels in one part of an array, it knocks that whole array out with your inverter, or it did last time I knew anything about doing photovoltaics. That is why Enphase has.
I think these are micro inverters. So
okay, that would do it. It'd be a micro inverters. Okay, that probably would do it. Thank you.
All right, Dale, thanks. Moving along, another Dale's question was, were there any issues to the local building authority in regards to the HRV in a box?
No, we didn't have any issues permitting that at all.
Great. Okay, like easy questions, easy answers. Moving along, Laura's question was, at the foundation base, why didn't you turn the insulation under the rain screen? And I thought you did in your detail.
What we wanted to do is we wanted this insulation to go like from the from the exterior wall down
Yep.
past the slab edge. And in some cases, the slab jogged a little bit, so we would have had to, you know, put it down there and then almost create like a frost wall where we would angle the insulation out from the wall in order to sort of tackle some of the slab losses. But I don't know. It seems like you would still have a joint there that would, you know, cause some thermal issues and maybe even some air tightness issues if you just stop right there.
George had a question about windows. George?
This may have been the presentation, I missed it, but the driver for reskinning, removing the brick was it was going to fall off by itself. But what about the windows? Was it just at that point, we might as well do the windows as well? Because that's a huge other hassle and expense. And then whose windows did you use and why?
The windows were pretty bad, you know. I think they were aluminum sliders maybe. And I think at this point, you know, windows, you know, they were just past their service life, so they needed to be, and they weren't installed correctly. So if they were good windows, we probably would have pulled them out and reflashed and reinstalled them. We've done that before, but these windows just needed to go. Ken, do you know what kind of windows they are? I know parts of it came from Poland.
Yes, they're one of the extrusions that carries a bunch of different labels in the States. So these were Vistaza.
Salem,
you had,
yeah, I mean,
yeah. So there was quite a you had quite a window search. We had an elaborate spreadsheet to evaluate the options, and it was a number of you know, would have been fine windows, and it just came out to which manufacturer could offer the best price for this project.
I'm sure a spreadsheet that everyone will love, because again, windows are always a tough decision, especially when you're, you know, dealing with the scale that you did.
so yeah, so what we do on the windows is, you know, when our CPHC does a whoopee model and they make assumptions and we get a model that we sort of like the results, then we take all that performance criteria of the windows and put it in a you know, a spreadsheet, and then let the builder try to find windows that meet that criteria. And, you know, we have windows that we use on projects that we sort of suggest to them, but you know, that just seems to be sort of an organized way to sort of make sure that you're not, you know, trying to confirm if a window meets the performance that you need it to perform for your passive house certification.
So in this particular case, because they're coming from across the pond, so you guys had an installation team locally that, you know, knew them. And so then of course you got to ask the question, did you guys have a mock-up? I love mock-up. So how did you guys train the window installation team or review those kind of details?
So we required a mock-up. And one day I think Ken and I showed up. I don't know if it was the third time we were out there to see the window mock-up.
It's the third mock-up.
And the rough opening wasn't the right size. We had them put a mock-up in the building, and it was just enough too big that you didn't really even have to use any shims or screws to keep it in. So the mock-up became our building, and we tested a lot of windows. And so we typically do a mock-up, and that's where we get the window installation right. We have the reps come in, you know, help show the subs, because it's not hard to get that wrong, the installation of the windows.
Yeah. And you also do your air and water testing on the mock-up, which is key. You want to figure these things out before you start throwing them up in the building.
So again, all the builders that are on here today, again, give your developers, architects, your consulting team a mock-up and get it done the first time, because their time is precious. So get the mock-up.
And get fee for it. You might as well.
Yeah, we'll pay you for that.
Hey, they said it right there. I think that's one we clip. Hey,
Yeah.
they'll pay for the mock-up. No, that's great stuff.
It's way cheaper than pulling windows from an high-rise.
Absolutely. All right, Mr. PH Molnair, it's over to you.
All right, good. I'll just go to the questions. Great presentation. What was the chosen finished roof surface? And was the coping on the parapet walls allowed to ventilate to allow accumulating moisture to evaporate out?
Gosh,
That's supposed to be a tough
believe
question.
yeah, we ended up with TPO, I do believe.
Yeah, it's mechanically fastened. I do know that.
And the top of the wall, the rain screen does vent out. We have the roof membrane tied in with the air and vapor barrier underneath the roof. So that is all tied in together.
Any final words before we dive into the final 15?
Just thank you so much, Julie and Ken, for being the first ones to figure this stuff out. Like, it is hard to be first, and it is hard to figure this stuff out. And I don't know how you pull the financing together. Like, I know you have a great team, Julie, but like, it's amazing. And yeah, so just everybody learn from this. And I will say, like, Julie has an amazing, she mentioned her basis of design stuff that POA has. If you work in affordable housing, look at that. I used to look at it all the time when I was at homeowners rehab, because they have done the work on what you should be asking at unit turnover and building new, and like, learn from other people. So thank you both. And thanks everybody for coming.
Yeah, great stuff, Bevan. Again, Julie, I appreciate you've been one of the regulars on the Accelerator right from the beginning, and you've always provided great examples, and being able to showcase your work is just a great opportunity for us, because this is one for the books. And like I said, we want to have you back because the story that this is creating and the other projects you've got in the pipeline, it's just amazing. So thank you for your leadership and that fine line of being on either the leading edge or the bleeding edge. And I'm not sure sometimes where you feel about that edge, but we sure like that you're there. So again, appreciate you joining us. Now that kind of wraps up the first hour. We will dive for another 15 minutes as we try to wrap up the questions. So Julie, hopefully, and Ken, we can keep you there. While I bring up the next question, Ken, do you want to just type the window manufacturer into the chat? There's a few people that had questions about it. They didn't catch the name of it. So if you don't mind doing that, I will pull up the question queue, which we Peter, we'll come back in a second about that roof detail, but we'll continue on. Paul, you had a question about the window sill details, and this is kind of getting great. We're kind of moving away from the project showcase to the construction tech questions here. So Paul had a question about the window sill. Paul, do you want to go ahead and ask it?
Yeah, I just wondered whether the rough opening was flashed and prepared with fluid applied or peel and stick.
I think the builder, and Ken, you correct me, the builder wanted to use fluid applied, but they were trying to install it in the dark. And so we made them go to a membrane flashing.
Okay.
And I'm teasing about the dark, but it looked like they were doing it in the dark.
It was an issue with the sequencing, right? They have the lift there. They got to flash the opening, get the window in, and the fluid applied with those windows. I think they were, larger windows were over 300 pounds, and they are a very effective squeegee for fluid applied membrane. So it was a lot of work to get the process to actually lay down shims before the weight of the window hits on the sill, and that you should always do. But we had to convince them to lay down the shims first, then put in the window and slide it in, because even the peel and stick would have gotten torn up with those windows.
Great. Well, again, you definitely know, like, as the next projects, definitely showcase those details and let us know, because I know Paul and a few other of us in the construction tech stuff love the nitty gritty of those details. Jay Murdoch had a question. Jay, I think you're still with us. I think I saw you. Go ahead, Jay.
Thanks, Sean. Julie and Ken, from this project and your others, are there any requirements from Passive House, Energy Star Code, or whatever that you would suggest could be revisited to kind of remove some pain or reduce pain in the process without compromising performance?
Yeah, and I'll let you answer that one.
Yes. So
say yes, and then it depends, and then you're done.
Right. There's some obvious ones, right? Like with an occupied building. Oh, and Julie, you didn't mention that there's also asbestos containing material, so that full remediation anytime we made a hole, which was, that was, and there was a pandemic going on and a supply shortage. So it was a hoot. But things like plumbing in the walls, well, if it doesn't get you hot water to the tap, within a half gallon, we're not going to open up the walls and redo the plumbing distribution. So that's one obvious example of it is what it is. We had many others out there, but I hope that's a satisfactory answer for now.
And I think, we'll continue to work with Phius once we get, our final blower door test and, test and balance, getting, everything started up and everything sort of wrapped up. I think we'll probably go through what we accomplished with Phius and see, they may have the exact same question, like, then they may alter their revive, program, accordingly.
Well, and again, too, I mean, the fact that you made the effort and you're the first, I think there's also a little bit of like, you get the pat on the back for taking the effort and understanding a few things. And so, sometimes it's like, hey, you get the award for being first, even though you might have missed the mark slightly. There's, an A for effort in some of these cases. So, and again, like now you have the model, you have the data, you have the techniques and the learning curve to be able to take this to the next project where a lot of others haven't. And the fact that you're sharing that knowledge, I mean, we're all grateful for this, and I'm sure there'll be lots of discussions at the Phius Retrofit Summit about this project and other ones that you guys are up to. So this is just great stuff. Carmel left us, but she had a question, which is I'd like to dive in. This is, she says she was shocked by the higher SHGC on the final windows. Are there interior blinds to help combat that gain? So the solar heat gain coefficient of the windows. So maybe Ken, I'll just ask you.
No.
Okay.
And the solar heat gain coefficient, that was center of glass. So I think, and we did reduce the size of the larger units. And we were really up against how low we could go with the solar heat gain coefficient and not have it look like we're viewing the world through sunglasses from inside the unit. As it is, it certainly is when you compare an open window next to the glazing, it does certainly take out a bunch of the visible transmission. So it's
we run into that in Florida a lot. We want, especially where we have that kind of heat gain potential, but they start to look real green and real funny from the inside. And
I'm sorry, I must have missed it. What was the solar heat gain? Do you?
I can go back and.
No worries, I somehow I missed it, but like I'm curious now when you're saying higher, because the fact that you guys looked at that and had in the model and looked over things,
I'm pulling up the quote now.
No worries.
I'll put that in the chat.
Interesting question too, just on certification. How come you guys chose Phius versus PHI?
I don't know how to answer that question. We haven't done a PHI project. Okay. I find, I'm certified CPHC through Phius, and I don't know. I like that program, but I haven't really ever looked at the other one.
No, that's fine. I think we're through the questions, Kim. Did I miss one? Sorry. I know I fired through a couple. Oh, sorry. We were going to talk about Peter and the roof details. I don't know if we want to pull up the slides to look at that, Peter. Or are you happy with what? You're good? You're content? Yeah, I know in the detail again, Julie talked about there's a lot of wood in that parapet detail, and she would have liked to maybe removed it or reduce it, but at least gave her that connection to ensure that that corner had enough wood in it, enough support to then lap to all the extra exterior insulation that needed on the roof deck. So
yeah, the wind loads here are insane, and that's why it took a lot of structural engineering to sort of make sure that we could attach anything to the stud and make sure we get enough screws through the armor wall, and then enough spacing for the PV array, because that weighs that's different weight than the aluminum panels, and then just getting the roof edge right. And it's the sequence is never ideal. I think the GC wanted to have the roof be done exactly when the metal panel was done at the top, and I don't think that happened one time. So there was a lot of conversations about that detail.
Yeah. So, my guess last question for the event is, so we had some walls at solar panels. Would you kind of be like our good friend over at Onion Flats and do the whole building in solar panels, or are you happy with just with the detail that you got away with on this particular one?
We looked at all of them, right? But we just don't have that kind of exposure, and there's a lot of in and out on this building. So there was a lot of shadow from, we even hold it, right or left in order to avoid shadow from some of the ways that the building jogged in and out. We're looking at it for the fair weather projects.
Yeah.
Just to help us get to net zero. One issue that we have on the fair weather project and Salem is that one of the roofs is covered with cell equipment. And so it's gonna, put a real damper on getting rooftop solar there. I don't know that, I think we have one of the fair weather buildings, one of the 4 has really good wall exposure that we could put some more, anxious to see sort of what our production looks like from that wall.
Well, again, it's just, unique as we try to get to that net zero point and try to find solar. And on your taller towers, you don't have a lot of roof space to put solar panels on. And as you said, if another utility has taken over the space, then you're left with putting it on exterior walls. And again, the fact that we're able to see more of these buildings and try to convert the market to like solar panels and see them on walls and surfaces is pretty unique. So, well, it's time to let everyone get back to work, get back to things. I don't know where you are in the world, but we thank you for joining us this morning, this afternoon, or this evening, wherever you're at. And from all of us at Accelerator, Ken and Julie, thank you again for your insights and the presentation. And again, we hope to have you back soon because there's lots more to learn from you. And so appreciate all your hard work and effort and keep fighting the good fight. We're here cheerleading you on. And if you ever need assistance, this community is here for you guys and just great work. And again, bravo to you.